In this question, we're told the circle C has a centre A and radius R. The points P, -2, -3, and Q, 8, 1, are at the opposite ends of a diameter of C. A part I says to write down the coordinates of A. So as this is a geometry question, it's always a good idea to start off with a sketch of the scenario. So I'm just going to sketch a circle. Now P, -2, -3, and Q1, well, both the X and the Y coordinates for Q are higher than P, so I'm going to put the point P down on the bottom left here. So there's the point -2, -3, and Q I'm going to put up here as the point 8, 1. And so here's my diameter. I know that the centre, point A, is in the middle. Now to find the centre, point A, well, we know that the diameter, the midpoint of that diameter, is the centre of the circle. So A part I, we're just going to find the midpoint. So A is going to be 8 plus the -2 over 2, and 1 plus the -3 over 2, so that we get A is equal to 8 minus 2 is 6 divided by 2 is 3, and 1 minus 3 is -2 divided by 2, which is -1. Part 2 says show that the radius is root 29. So what I'm going to do is I'm going to find the diameter and I'm going to half it. So you could do the radius directly from the centre, but I'm choosing to do diameter because I know at this point that the coordinates for the diameter are correct. So I'm going to get 8 minus -2 squared plus 1 minus -3 squared. So here we end up with 10 squared plus 4 squared, so root 116, which can be rewritten as root 4 times root 29, and you've got a calculator that will simplify for you. That's 2 root 29. So the radius is in fact equal to half of this, so I don't need the 2 actually. Let's get the rubber there a second. All I need to do is the radius is equal to root 29. Okay, let's have a quick look to see how you all did the marks on this question. So initially there is just a standalone mark for getting that the midpoint is 3 minus 1. There's then a method mark for a correct method to find the distance, the length of the line, and an answer mark if you've got the radius is root 29, and that's convincing. Okay, let's have a look at part B. Part B says given that the point 54 lies on the circle C, find PQR and give your answers in degrees to 1 decimal place. So again, need to sketch this. We already know where P is, so I'm putting P down here. That's -2, -3. Also know Q was somewhere around here, which we're going to say is 8, 1. So here's my diameter. The point 54R would be to the left and higher than Q, so here's the point R, which is 5, 4. Okay, now if I complete this and make a triangle, what you should know from circle theorems in GCSE is that any triangle inscribed in the centre of inside a semicircle, where the hypotenuse is the diameter, gives a right angle on the circumference. So this means that I could use trigonometry to find the angle PQR. So the angle PQR is my angle here. Now what I know is that the diameter is 2 root 29. So what I need to find is either PR or RQ. It doesn't matter which side. I'm going to find RQ for argument's sake. And I'm going to use trigonometry because once I've got this side RQ, because it's a right angled triangle, I can use standard trigonometry. So RQ is given by the square root of 8 minus 5 squared plus 1 minus 4 squared. So I get 3 squared plus -3 squared, so I get 9 plus 9, which is root 18, or if you simplify that, you get 3 root 2. So now I know the adjacent side to that angle. I can use that just, if I call it cos theta equals adjacent, which is 3 root 2, over the hypotenuse, which is 2 root 29. And if I take the inverse cos of both sides, we get that theta equals 66.8 degrees to 1 decimal place. Okay, let's have a look to see how the marks were awarded in part B. First of all, there is a standalone mark if you have got RQ or if you've correctly got PR. There is then a method mark for using standard trigonometry, depending on what sides you've used in the triangle. And then finally, there is an answer mark if you got that led to an angle of 66.8 degrees. Okay, finally, let's look at part C of this question. We're told that the point S lies on the circle C, and the tangent to the circle S passes through the point T, which is 11, 0. Find the length of ST. So again, need a sketch of what's actually happening here. So we know that the centre of this circle is 3 minus 1. So then the point 11, 0 is further along and slightly higher. So if we just put the 11, 0 here, that's T. So this one here was A. T is 11, 0. So what I can do is I can connect that up. I know I've got tangent coming down here. And if I draw the radius to that tangent, what we should remember is that is at a right angle. And that's the point S. Now what I know from previously in the question is I know that the side AS is the radius, so that is root 29. I'm looking to find this length ST. I've got a right angle triangle, so I'm going to use Pythagoras. What I need to know though is AT. I can't directly find ST because I don't know what the point S is. So first of all, AT, this is going to be given by the square root of 11 minus 3 squared plus 0 minus 1 squared. So I get 8 squared plus 1 squared, which is root 65. So then finally, using Pythagoras, ST squared is equal to AT squared minus AS squared, because I'm finding a side which isn't the hypotenuse, so I'm just rearranging that. That's AT squared minus the other side. So we get the ST will be the square root. So if I take square roots of both sides just to speed things up, AT squared, so I've just found that that's root 65, so I've got root 65 squared plus AS squared, which is root 29 squared. Please remember that's not plus in the middle, so apologies, that's just force of habit from using Pythagoras. It's minus. So what we get is 65 minus 29, which is 36. Square root of 36 is 6. Okay, let's have a quick look to see how the marks are awarded in this question. First of all, there's a standalone mark if you found that the side AT was equal to 65. There is then a method mark for the correct use of Pythagoras and an answer mark for getting that the length ST is 6. Okay, well I hope you was able to follow all of my solution and that you understood how to mark that question.